3. How does AI work? Artificial intelligence, AI, has evolved through various techniques that allow machines to learn and make decisions without direct human intervention. AI works through learning algorithms, the most relevant of which are machine learning, ML, and deep learning, learning, DL. These algorithms allow machines to learn patterns from data and perform tasks without being explicitly programmed for each situation. The two most important ones. Machine learning. It relies on predefined rules, machine learning models, that require a lot of manual work to process the data. Deep learning. The deep learning, neural networks can automatically learn complex patterns from large volumes of data. How this learning or training is carried out. 1. I learned from books and articles to understand how language is structured. 2. It predicted the next word in a sentence, improving its ability to generate coherent text. 3. It could adapt to different tasks, such as answering questions or summarizing information, without needing to be retrained from scratch. Machine learning allows machines to learn patterns from data and perform tasks without being explicitly programmed for each situation. Instead of following fixed rules, algorithms identify regularities in information and make predictions or decisions based on them. To do this, as in our learning processes, but with greater attention and analysis capacity, you are provided with an input data set with known answers. The model analyzes the data and detects patterns. Model parameters are adjusted to improve its predictive ability. Once trained, the model can make predictions on new data. There are three main types of machine learning. 1. Supervised learning. The model learns from already classified examples, like a teacher teaching a student. 2. Unsupervised learning. The model looks for patterns in the data without knowing the answer in advance, such as organizing unlabeled photos. 3. Reinforcement learning. The model learns through trial and error, receiving rewards or punishments, like training a dog. Let's look at this with machine learning examples. The first is supervised learning. It's similar to how a child learns from pictures. In supervised learning, training is done with labeled data. It's used for tasks such as classification and prediction. Example: imagine you're teaching a child to distinguish between an apple and a banana. You show them several pictures and tell them, this is an apple, and this is a banana. Then, when you give them a new picture, they can correctly identify the fruit because they've learned from previous examples. The second of these is unsupervised learning. It is trained on unlabeled data, searching for hidden patterns. It is used for clustering, segmentation, or dimensionality reduction, data simplification. Example: you have a lot of photos on your phone and want to organize them. An AI system can group images with similar faces, without you having to tell it who's who. It doesn't know the names, but it finds patterns and separates family photos into different groups. Another example is the learning that DeepL, the translator, performs when the user improves the translations given to him. The third of them is reinforcement learning. An agent, application or program, learns through trial and error, receiving rewards or punishments. It's used in robotics, video games, and autonomous driving. An example of this is the recommendations platforms like YouTube make through trial and error. The algorithm improves its recommendations, maximizing the reward, more viewing time, and avoiding unappealing suggestions. Reinforcement learning allows digital platforms to tailor their content to each user's individual tastes. Deep learning, DL, is a branch of machine learning that uses artificial neural networks inspired by the workings of the human brain. These networks can handle large volumes of data and learn complex representations without human intervention. It uses artificial neural networks with multiple processing layers. Each layer transforms data into more abstract representations. It can automatically learn features without requiring a human to define explicit rules. Example: facial recognition in photos. Previously, if we wanted a computer to recognize faces, engineers had to manually program features like the distance between the eyes or the shape of the nose. With advanced AI, the system learns on its own which details matter, without anyone telling it what to measure. Google Photos can automatically recognize family members' faces in old photos without the person having to label each image. It can handle large volumes of data and complex tasks like speech recognition, Siri, Alexa, or Google Assistant can understand and answer questions because they've analyzed millions of voice recordings in different accents and intonations. This would be impossible if a human had to write all the rules of language by hand. Some phones or devices can convert what someone says into text, allowing people with hearing loss to read instead of listening. All of this requires greater computing power. More powerful processors. CPU, Central Processing Unit. This is the main processor of a typical computer. It is designed to handle general tasks, such as running programs and managing the operating system. It has a few cores, usually between 2 and 64, optimized for sequential processing and general-purpose tasks. GPU, Graphics Processing Unit. Designed to handle parallel calculations, especially graphics and image processing. It has thousands of smaller, specialized cores that perform many operations simultaneously. It's essential in gaming, video editing, 3D modeling, and deep learning. TPU, Tensor Processing Unit. Developed by Google specifically for artificial intelligence, AI, and machine learning. Optimized for handling deep neural networks, which requires huge data centers.